Good morning or good afternoon, wherever you are in the world. Welcome to the Romax Technology Technical Due Diligence How to Quantify and Minimise Technical Risks of Your Wind Projects webinar. Thank you for joining. I'm Rahini Sayal, Romax Marketing Campaign Manager, and our presenters today are Dr. Francesco Cornacchia, Business Development Manager for Romax Insight, and Evgenia Borshiva, Head of Consultancy at Romax Insight. The presentation today will last approximately 25 minutes with a 10-minute Q&A session. Let's get started, and I'll hand over to Francesco and Evgenia and let them give a full overview of our technical due diligence services. Thank you.
Thanks, Rini. Good morning or good afternoon, everybody, and thanks for attending our webinar. My name is Francesco Cornacchia, and I'm with my colleague, Dr. Evgenia Golisheva. During the next 20 minutes, I'll introduce how the technical due diligence performed by our company can help you to quantify and minimize the technical risk of your wind projects. As you all are aware, technical due diligence needs to cover several aspects of the project. In today's webinar, we will focus on the technology assessment of Gearbox and Drivetrain and OPEX modeling, showing some results based on real data. First of all, a few words on Romax. We like to think that we are a different company. Starting from a highly scientific approach and in-depth knowledge of drivetrain design, Romax has developed a hand-on expertise through the service provided to worldwide operational assets. We started more than 25 years ago in 1989 as an automotive software developer, improving design capability for gearbox design. To date, we have more than 12 offices worldwide with a staff of more than 220 people. Our clients are the industry leaders like Caterpillar, Rolls-Royce, Ford, Honda, Mitsubishi. Through the years, this has seen Romax applies expertise to different markets, eventually ending in the wind industry. And for the wind industry, we developed a software called Romax Wind, which models wind turbine drivetrains through dynamic load simulation. We now have supported our clients in the design and certification of over 39 DNVGL-approved wind turbine gearbox designs. In parallel to this, we have utilized our practical expertise for validation through custom test rig development. Romax is also performing monitoring of wind farms from our monitoring centers in Asia, EU, and US. Our qualified team performs inspections on behalf of our customers in every corner of the world, and we are committed to the continuous improvement of the gearbox design with our R&D team. Finally, we support the various players of the wind energy market with our services of independent engineering that include wind energy assessment, contracts review, interconnection agreement, from the inception phase through development, financial closure, construction, and operation of the wind project. So going to the core of the presentation, the drivetrain. The winning strategy of the wind energy sector has been your ability to reduce the LCOE, the levelized cost of energy, during the last 20 years. This cost reduction has been achieved working on several aspects of the projects, and efforts are continuing under the current energy market pressure. The challenge has been accepted by the O&Ms that have responded by introducing new design concepts to the market. Broadly speaking, drivetrain can be split into two main categories, the evolutionary and the revolutionary design. The evolutionary, it's a well-established 3-point or 4-points mounted design where the main shaft is supported by one or two main bearings mounted on the bed plate. Rotor thrust and off-axis loads are taken by main bearings. One of the advantages is related to the possibility to separately replace main bearings on the gearbox. On the other side, in the revolutionary design, you have the main bearing that is integrated into the gearbox. The off-axis loads are taken by the bearings inside the gearbox, either the main bearing or the planet carrier bearings. In theory, these concepts provide better reliability, however might make replacement of the main components more difficult. The integrated drivetrain modular design of 3 self-contained modules provide ease of assembly and replacement. Anyway, because of the novelty of the design, it brings in higher uncertainties of future failure rates. As of today, modular designs are the most commonly used in the wind industry. They have been used for wind turbines for many years, but it does not mean that there is no uncertainty associated with technology assessment. The diagram in this slide shows how quickly rotor diameters have been increased in recent years, reaching more than 100 meters nowadays, which leads to change in operating loads, speeds, lubrication, and ultimately reliability of the design. At the same time as rotor diameter, gearbox design are also rapidly changing. The push to increase power density in order to reduce the capex. In these slides, we split them into the 3 main categories that you can see working nowadays. So the first one for power up to 2.3 megawatt is the single planetary. Then you have the double planetary for wind turbine generators in the range between 2.5 and 6 megawatt, and then the split torque for power above 3 megawatt. What are the features of those three different gearboxes? So the single planetary with two parallel stages layout is well established with various up-tower repair and replace methods available. It has established refurbished market. The gearbox performance under variable load is very well understood nowadays. On the other side, the double planetary with single parallel stage layout is newer. Potentially, as we were saying before, it leads to larger O&M expenditures as planetary stage are not repairable up tower. Furthermore, fewer gearbox suppliers are available in the market for both new and refurbished gearboxes. Finally, the CMS is more challenging on planetary stages, giving rise to difficulties in data analysis and interpretation. The split torque design is more compact but more complex. It is potentially more sensitive to manufacturer tolerances and refurbishment processes because of the increased number of components. So, in the drivetrain technology assessment that represents the core of our expertise, it is useful to think about the following points. The drivetrain topology. How novel is the design? How sensitive is it to the operational loads, wind shear or turbulence, for example? Moving on to more detailed design assessment, you need to think about the status of field validation. What prototype testing has been performed, any turbines have been installed in the field, what new technologies have been used on the bearings, are there any fundamental differences between gearbox suppliers? For example, you need to look at the historical performance of gearboxes from different suppliers, their track record, and especially their design principles. During this phase, you need to assess how sensitive is the design to the manufacturing processes, as this might introduce an additional uncertainty to the performance of gearboxes manufactured or refurbished by different suppliers. You also need to take a lot of care understanding the supply chain of major components. Components that can only be manufactured by a single supplier can make you vulnerable in case of serial defect, manufacturing issues, or simply carry longer lead time with it. Finally, you need to carry out operational assessment. What components can be replaced up tower, what failure rates can be detected in advance, and by which tools. Just to give you an idea, the graph in the bottom right shows how sensitive is the high-speed bearing life to installed clearance. The 50% of bearing useful life is lost when the 100 micrometer clearance is not achieved. For the reference, the diameter of a human hair is just 89 micrometer, and is also shown to highlight the sensitivity of some designs to the build and installation tolerances. Trying to achieve it while replacing bearing on the top of a swinging tower, that's very difficult, and we understand how this is a critical parameter nowadays. The next very important step is quantify technology risk in long-term OPEX forecast. This is of paramount importance when preparing the business plan in case of refinancing, for insurance purpose, or in general in any moment of the operational phase. At Romax, we use our database, which contains information from approximately 10 gigawatt of our project, the failure rates of the major components, the performance, and the site operating conditions. We then assess site operating conditions in the sense of turbulence of the site, the complexity of the terrain, what's the capacity factor of the wind farm. The next step is to adjust our historical failure rates to the site-specific operating condition. This is typically done with all major components, gearboxes, blades, main bearing, plus additional technology-specific components should be included. We are currently seeing increasing failure rates for the pitch bearing. Also, in our experience, failure rates for the main bearings tend to be underestimated. The final step is to review the maintenance. What are the regional costs for major components? What is the availability of capital equipment? What is the maintenance strategy? Is, for example, a CMS installed on the site? Then the experience of the site team with dealing with major maintenance operation. For sure, you need to take care about logistics of the part supply, how many parts are available on site, the way they have been stored, because also storage can have an impact on the quality of the material. After that, it's just a matter of multiplying forecasted failure rates by expected cost. The resulting model gives us site and region-specific cost forecast. In comparison with models simply assuming constant failure rate during the lifetime of the project, this model allows accurate estimation of the OPEX cost for each year of operation, which can be used to analyze different scenarios or maintenance strategies, return of the investment, of equipment upgrades, or condition monitoring systems. The OPEX sensitivity to different parameters can also be assessed which can be used for contract negotiation with O&Ms or service providers. So access to good quality data is of paramount importance. You need to consider several aspects in this phase. Even if you are the proud owner of the squiggly line, there are a few more things that you need to consider before you begin to use it for your forecast. So the major component supplier. The same turbine can use different gearboxes from different suppliers with very different failure rates. Make sure that this information is supplied for each of your turbines. The design upgrades. Do they address the failure mode? Often, the main bearing is replaced by a larger bearing, which in some cases can worsen the performance rather than improving it. Refurbished components. This is a very important point nowadays. At the moment, everyone assumes that the quality of the replacement part is going to be the same as the original. In our experience, this is not often the case. So it is very important to establish good processes with your suppliers of refurbished components. At the very least, you need to ask the following information. What is the original failure mode? The operating hours of the original components, what component have been replaced or remanufactured, and please insist on good traceability and quality control. We have already mentioned the importance of operational condition. It is very easy to over or underestimate the failure rate when using data from very different sites. And last but not the least, maintenance quality. Even the best design in the world would not last without lubrication, and we have seen a lot of turbines where all of auto greaser were disconnected because they were causing too many alarms, resulting in main, pitch, and your bearings running without any lubrication. So this is the case when you have a lot of data, but what if there are no failure data because the design is new? At Romax, we use our Romax Wind to produce a model that can be tuned to historical performance data and then used to assess the new design. In the picture, you can see an example of our main bearing. We have created a relatively simple model of the main shaft, tuned it to match contact pattern observed in the field, and you can see that the upper wind race of the bearing, that's the picture in the bottom left, does not take any load as observed in the field. There are still machining marks evident on the picture below, while downwind races takes all the load. While distribution parameters fitted to the historical failures are also matched, and you can see in the graph just in the bottom. Once this is done, this model can be used to analyze return of ROI for possible improvements, changes to lubrication, maintenance, or even new designs. Now, beyond 20-year life, a new problematic that the wind sector is already experiencing and that will be even more relevant in the near future is the one related to lifetime extension. Can the turbine be kept operational and productive beyond the predicted 20 years life? Our approach based on both data and simulation is very useful when looking at the visibility and cost forecast for the life extension scenarios. Currently, only qualitative assessment is expected from an independent engineering firm when asked about possibility of life extension. And while addressing many useful points, such assessment introduces high uncertainties and is unlikely to be accepted by financial institutions. At Romax, we follow a different approach. First of all, the difference between design loads, which are typically more conservative, and actual site loads can be established analyzing site wind data. Then, simplified aeroelastic turbine model can be run to quantify operating loads experienced by the turbine during its operation and estimate remaining useful life of the major components. After that, combined with the O&M model, different scenarios can be analyzed, providing greater confidence in future cost and performance. And I will leave you now the word to you for any question of clarification.
Thank you very much, Francesco. I hope you found our presentation useful and informative. As Francesco said, now let's begin our Q&A session.
It seems that we have some questions. Since the majority of them are related to the OPEX and simulation, I will leave the word to Evgenia, that is our responsible just for the OPEX and simulations side. So, Evgenia, please, if you would like to read and answer to the questions.
Thank you, Francesca. OPEX modeling done on OEM specific, site specific. Yes, the answer is yes. Each project is very different. The same turbine can perform very differently at different sites. So we always do it region specific, site specific, and technology specific. How OPEX cost can be estimated during beginning of plant operation? It's a bit more difficult because we don't have a lot of historical data to rely on, but it's done in exactly the same way as we do it for operational projects. We look at technology, we looked at historical performance. If it's very new turbine, we use the closest available technology, and then we extrapolate the data using site operating conditions. How long does it take to run simulation and get results? It really depends on the simulation. The models don't need to be very complicated. The example that Francesca showed is a simplified model because we focused on a specific failure mode that was affecting performance of the turbine. So it doesn't need to be very complex. It doesn't need to take a long time to run. What software tool do you use? Mostly we use our Romax wind software to simulate performance of the drivetrain. We have in-house ANSYS, which we use to analyze structural elements. And that's probably two main tools. One question, probably Francesca?
Yes, I see one is related to the evacuation, transmission, distribution, BOP, HSE. What's our take on them? So I started saying that technical due diligence is really a wide subject. It can cover every single aspect. So in my opinion, the key points when you have to study a new project and understand whether it is feasible or not, for sure you need to look into the evacuation and the interconnection agreement, essentially, because without a connection, any project has no way. And electrical layouts and ESC capabilities for sure. The topic of today's webinar was mainly on the components. We will have other webinars in the future where we will take it on. We try to give the same weight depending on the phase. So if you are in the greenfield development phase, we will put more importance to the wind resource assessment, to the kind of an interconnection agreement and the difficulties related to the site logistic. When we enter into the finance side and the negotiation of the contracts, then the BOP is the one that takes the most relevant part, because in this phase, you really have to understand whether there is any technical issue related to the selection of the turbine, depending on the site. And then once you have those, you have to start looking into the EPC contract and O&M contract. Those are the ones that are really giving the full availability and the better performance of your wind turbine. As we have shown from the examples, you can have the best turbine, but the site is not the best one for that kind of turbine. Or you can have both the best site and the best turbine for the site, but your O&M strategy is not the best one, either because you don't have the proper O&M strategy, or either because the O&M team is not the right one. So depending on the different phases of the projects, we need to put the accent on what is the most relevant point in that moment. So at the beginning, as I was saying, wind resource assessment and interconnection. Once we start the negotiation, the BOP and the selection of the material. Once you are ready to start the operation review of the EPC and O&M contract. And then health and safety all over the project.
There's a few more questions. Does Romax software used for condition monitoring of drivetrain only? So the Romax wind software used for modeling of a drivetrain. For condition monitoring of the turbines, we have another software that we've developed called Fleet Monitor. It's a hardware-agnostic tool. It can interface with different CMS providers. It also brings in SCADA maintenance data, oil lubrication analysis, allowing you to see everything in one portal and make the best of it. Another question is, that's a very good question. What is real average gearbox lifetime for projects where estimated gearbox fatigue loads are just 20 years? Yes, it's the biggest surprise in the wind industry. None of the gearboxes last 20 years. The average gearbox life we see in the field really depends on the manufacturer, on the maintenance, on operating conditions. For average that we see in the field at the moment, probably mean life of about 16 years. That means that 60% of your gearboxes are likely to fail before that time. Which year the gearboxes start to fail? Again, it depends how good design, how well it's maintained. We see a lot of infant mortality failures during the first few years of operation. If you pass that stage, then maybe you begin to see something of significance in year 7. There's one last question. What are the key technical risks of wind projects? Resource assessments, as it always has been, but in recent years, we see technical turbine assessment becoming more and more important. Previously, everyone focused on top 3 technologies. Now, apart from the designs that are produced from those technologies, there are more turbines on the market. The market became more competitive, so people go in further fields and technology assessment becomes more important. If you have any more questions, drop us an email. Thank you for your time today.
Unfortunately, as Evgenia said, that's all the time we have right now, but our presenters will answer any remaining questions by email. If you have any questions on this webinar topic or require further information, please email marketing@romaxtech.com and we'll get back to you as soon as possible. You can also visit the webinar section on our website for more information on our upcoming webinars, and we'll also be sending e-shots with more information shortly. We hope you'll be joining one of our future sessions. Thank you and goodbye.